The idea is that these, let's call them micro-agents, individuals, persons, human beings, change with their behavior, with their evolution. Let me use this Darwinistic term. They change the properties of groups, and vice versa. Of course, there is an influence of groups on these individuals, persons, of micro-agents. So we're going to use this distinction in order to build our model. I mentioned at the beginning that we're going to make a distinction between influence and power. So let's draw a plane. In the plane, each point is a micro-agent, a person, human being. And we're going to represent only power, not influence. Power is the height of this hill. Here, this group of people has a lot of power. Here's a similar group of people with little power. This is the interpretation of the plot. But the important thing is that we're going to consider the relationship between power and influence. We're going to borrow a concept from chemistry. When they consider reaction diffusion. Diffusion is a very boring process. Just when we add sugar to our coffee, finally there's an homogeneous and steady state. This. Here's the spoon of coffee, and here the final state. Diffusion. Very boring. Nothing happens. But imagine that the sugar reacts with coffee, then you have reaction diffusion, and what we get is new patterns, new structures. This is important thing. This is a model describing many phenomena, not only in physics or chemistry, but also in biology, study of populations. But as far as I know, it's the first time some crazy person tried to use it in a model of power. Sorry for that. These are two equations, but don't look at the equation, please. We try to describe two things. The evolution of power in a point and evolution of influence in a point. Okay? Don't look at the formula, don't look at the equation, but look at the meaning of the terms. This is the rate of change of power of a person in a point. What we are saying is that the more power you have, the more power will you get in the future. So power usually increases with power. Okay? Positive term in red color. This is negative. This is a negative term, meaning that power decreases with influence. And this is the diffusion. Power spreads. Power is transmitted to your friends, the members of your party, and so on. What about influence? The influence here has a negative term. The rate of change of influence is described by decreases with P. The more power, the effect of influence is bigger in decreasing power. And also, this delta means the spread, the diffusion of in this case, of influence. Influence is transmitted also. Well, what I want to say with this equation is that the effect of barriers, according to Moises Naim, is represented in the coefficients of these equations. And what we are describing with these equations, this can be, of course, discussed, is that the effect of influence is mainly repressive. It's a repression. That is, influence means that I try to avoid the growth of power of some people. Negative influence, repression. A weakness of this model is that we cannot distinguish for the moment between the four channels of power. We're talking about power in general. And of course leaves open many questions. If total power has a constant value, maybe power disappears too, evaporates, vanishes. Well, we have to take also into account that the future of power depends on the initial conditions, how many people have power in a certain moment, and also the boundary conditions. What happens when we lose power? Disappears or necessarily goes to other groups, other people? Well, Dr. Colasanti mentioned, raised the question whether or not the decline of power is a growing disease or a sign of transformation. Well, I tried to give an answer with this formal model, and the answer will be that it really depends on the coefficients, and we shall see. These coefficients tell us the speed of this influence, the speed how power grows, the speed how power disappears, and the speed how power spreads. Now, you have here some simulations that is much more easy to understand. This is a group with a big power, and this is a group with less power. When we run on the computer the model, we see that this group is losing power and finally disappears. So maybe we are reproducing the saying that the big fish eats the small fish, at least in this situation, in this moment. That happens with the equations. Remember that the hill means the amount of power. We cannot see the influence. The influence simply spreads on the plane. But we can see the effect of this repressive influence, this kind of competition. Well, second simulation. What happens if we have three groups of people with more or less same power? It's something that could be expected according to the interpretation of the equations. That means that the group in the center will receive more influence, more repression, and you see that the power of this group will decrease. You can see here there's a lot of noise because we carry out a long computation and some errors appear. But formally or qualitatively, that's what happens. The power of this group disappears. Another situation, what happens when we have two groups? One group here, small group with a lot of power, and a big group with some power. It seems that the equations say that this group will be reduced and the power will be more concentrated. I don't know what happens in the long term. But more or less, I wanted to show this to you because it describes more or less something that we can check empirically. And this is a very complicated situation when we have several groups clustered in three clusters, groups of power. You see that also the structure of the group is changing, and this group in the center has a very reduced power at the end of the run. Okay, these are many examples. Thank you for your patience, but let's go to the conclusions. I think that Naim gave us very nice examples in many different areas, not only politics, economics, or moral power. And he really seems to suggest that there's a possible end of power. But as far as I can understand, the problem is that there's a very complicated, subtle